Yeah, just said. Yeah, now I can see.
Okay, right now it's recording, correct?
Okay, okay.
Right. Okay, so Rashmi, right? So when we are talking about Hadoop, right? So
Mm-hmm.
every project in the Hadoop, uh, there are the three things. One is we have the different external resources are available, so where we have to collect the input data. Once the data is available in a Hadoop cluster, then we are going to process the data, and then either you have to store the data or you have to visualize the data. So every day-to-day activity, right, so which involves the three things: ingesting the data to the Hadoop cluster, then processing the data in a Hadoop cluster, then storing the data in a Hadoop cluster. So now we have given different ways here when it's coming to the data ingestion as well as the data processing. Okay,
Mm-hmm.
so now, uh, right, as we discussed the Hadoop, right? So the definition is distributed data processing system, right? So we'll dig a little bit more on what is the how the data is going to be distributed in a Hadoop cluster. Okay, so
Mm-hmm.
as I told that it is a the data is going to be distributed, correct? So
Mm-hmm.
let me show you one diagram here. Okay, so now think that so this is a one Hadoop cluster with some master nodes and some few slave nodes. Okay, so we'll see what is a name node and data nodes later. As of now, think that this is Hadoop cluster which is configured with a one master node and four slave nodes. Okay,
Mm-hmm.
right. So this is now Hadoop cluster. And remember, so whenever we are going to work in a Hadoop cluster, right? So like you can see, these are the five individual machines. Okay,
Mm-hmm.
you can say these are the five different CPUs. Whenever we buy a new disk, what we have to do? The very first thing, whenever we buy a disk or a new system, a CPU, first we have to install the operating system, right? So you have to configure either Windows or you have to configure the Linux. So then what I did, so to configure the Hadoop cluster, so we need some individual machines first. So like machine 1, machine 2, machine 3, or you can say CPU 4, CPU 5. So we got the different machines. Now, when we first get the machine or a disk, we have to install OS. Can we do anything without configuring or without installation of the OS? Anything?
No.
No, no way, right? So either you have to install OS in the at least we have to get only my DOS or Linux kernel at least to work with the commands. So without the OS, we cannot able to work. So the same thing
Mm-hmm.
here. So I brought a new disk, then I install the Linux in this machine. So when you install the Linux, so Linux will give you the Linux file system, right? So we'll
Mm-hmm.
get a Linux file system. Now what I did, so like this, I brought five machines, then I installed the Linux in these machines. So when we install the Linux, we got a Linux file system, right? Now we have to configure Hadoop cluster. So obviously you have to install Hadoop, correct? So then
Mm-hmm.
what I did after installing the Hadoop, so we install the Linux in the machine, Hadoop in this machine. I install Hadoop 2.7.0, some version we install. When you install the Hadoop, Hadoop will give you its own file system. Okay, so we call that file system as a SDFS file system. Okay, so now in one disk, how many file systems we are having? Two
Mm-hmm.
file systems.
Two.
One is a Linux file system and other one is a SDFS
HD.
file system. Correct. So now like this you are going to configure Hadoop cluster with the five data nodes. So in all the five machines, what we have to install? First we have to install the OS,
Operating.
right, operating system. So here you can use any Linux like Ubuntu, Red Hat, CentOS, right, Fedora. So we install the Linux file system. So whenever we install Linux, we got the local file system, or we call it as a local file system. So you can use either Linux file system or a local file system. Both works. Now, okay, right. After that, we have to install a Hadoop. So the admin, what he did, so first sysadmin will configure the OS in the machine, then the Hadoop admin configure the install the Hadoop. So now in each machine, so we have the two file systems are available. One file system is a local file system, and other file system is a SDFS file system. So now see, now each node, how many file systems are there in Hadoop cluster? Remember this, always we have the two file systems. One is a local and other one is a
Mm.
SDFS file
I see.
system. Okay, right. So next what we did, we have to process the data in a Hadoop cluster. The finally, at the end of the day, what we do in Hadoop, we have to get the data, then we have to
Mm.
process the data,
So,
right?
mm.
So suppose, Rashmi, I want to listen a song in my system, C drive, D drive, somewhere. Then what we have to do? First we have to copy the song, correct? We have to get the
Mm.
song. Then we need a player. But without
Mm.
getting the song, can we able to play? No, correct? First, you have to
Mm.
get the song. The same way, when you are trying to process the data, first we have to get the data to the SDFS file system. What we have to do? We have to make the data available in SDFS
Excellent.
file system. Once the data is available in SDFS file system, then we are going to process the data.
Yes, sir.
Right. So now see here, a client like this is you and in your system, right? Or a client machine. So a client is trying to copy a file, right? With a copy command or with a put command, a client machine is trying to write the data. Okay. So now what this client wants to do? So he wants to create a directory. So the client wants to create a directory with the command hadoop fs-mkdir. We'll see this command later. So he is going to create a directory prod. Okay. So
Mm.
in the prod directory, he wants to copy a file prod underscore info.txt. Right. So he wants to
Mm.
copy this file. Think that this file is a 1 GB file, that is a 1000 MB file.
Mm.
Okay. So what we are doing now, we are trying to copy the file. Correct? Which file?
Mm.
Prod info.txt file I want to copy to the Hadoop cluster. Okay, so how the data is going to be copied? As the discussion, data is going to be distributed, right?
Mm.
So here first the data divided as a small size of pieces or chunks. Okay, so we call these chunks as a blocks. Right?
Mm.
So first what input data is divided as a small size of chunks. Now it's everybody question. Small size means how much? Right? Small size means
Mm.
how much? So when you,
60.
yes Rashmi,
No, it's 64, right?
yes, uh,
Mm.
correct. So when you install Hadoop, the Hadoop installation comes with a configuration file.
Mm.
sdf-site.xml. We'll see these configuration files later. As of now, we are talking about the small size. Okay, so don't give much
Mm.
priority to this file. As of now,
Mm.
remember. So when you install Hadoop, Hadoop installation comes with a file sdf-site.xml. So in this configuration file, we have a property dfs.block. So what is the value specified for this block? That is going to be the size of the block, right?
Mm.
It can be 64, it can be 128 MB, or it can be 256 MB, or it can be 512 MB. Okay,
Mhm.
so generally the default one right now is a 256. Previously, before Hadoop 2.0, it is a 64 MB. Okay,
Mhm.
so now I'll take a simple here. I'll take, but to make the mathematics easy, I'm taking the block size is a 64 MB. Okay, so the default block size. What is the default one? The default one is the one which is specified for the property dfs.block. It cannot be a 64, it cannot be a 128 to 512 MB. It's based upon the property dfs.block.
Mm.
Okay, so now
Mm.
See here, the file size is how much? 1000 MB. But default block size is how much? 64 MB.
64.
How many blocks created? 15.6. That is, it created total 16 blocks are going to be created. Okay, that is the entire content of prod underscore info.txt is divided as a 16 blocks. Okay, any confusion here, Rashmi?
No.
Right, 16 blocks are created, like block 1, then block 2, like 16 blocks are created. And remember, in yesterday previous discussion, we are using commodity hardware, correct? Means
Yes.
reusable low-end, low-price machines. So which obviously goes down, correct? So what we are doing, suppose these are the blocks are created. Then after that, what we are doing, we are distributing the blocks to the Hadoop cluster. Okay, so what I did now, I have copied block 1 here, then like this, block 2 written here. Suppose if this particular machine goes down, then we are going to lose this block 1, correct? So what we are doing here, whenever first we are dividing the data as a small size of chunks as a blocks, so then blocks are replicated. Okay, then replicated blocks are distributed. Okay, so these are distributed such a way that if one machine goes down, then we can retrieve the data from the another machine, right? So like this. Now what I did, so we have 16 blocks are created, block 1, block 2, block 3. Then what we have to do, as these are the commodity machines, low priced machines, whenever one data node goes down, so what I want to do is I want to replicate these blocks, means I want to create a duplication. How it will be duplicated? So the same thing with the Hadoop installation, we have a sdf-site.xml. In this file, so we have a property dfs.replication. What is the property? dfs.replication. So it is set to 3. That is, default every block is replicated 3 times. Okay, so now just a second, Rashmi. Rashmi.
Yeah.
So we have a property dfs.replication. Okay, so which is set to 3. So this is the default one which comes with the installation. So and the control will be given to admin. So we are not going to change this. So now what we did here, so have the 16 blocks are created. Then we are replicating each block 3 times. So there is 3 block ones available. Okay, so 3 block 2s available. Like all the blocks are distributed 3 times. Got it now?
Yeah.
So now, so the actual data is a combination of block 1 to block 16. So if you want to read the data of a file, then you have to read the data from the block 1 to block 16.
Block 60.
Correct? Right.
Yeah.
So now, what we are doing here, so the blocks are replicated such a way that each block is replicated 3 times into the 3 data nodes. So we'll see this later. So the blocks uses a replication placement policy. Okay, so based on this rule, it contains some 3 rules. Based on the rules, these 3 blocks are distributed to the all the mesh nodes. Okay, so now see here where the actual data is available here in these machines, right? Uh, node 1, node 2, node 3, right? So here we have the block 2 is like, so block 3 copied here. So we have a block 4 available here, right? So block 5, like all the blocks are distributed here. So now the actual data is written into these 5 machines, these 5 nodes, right? So that we calling it as a data nodes. What we call? We call it as a
Right.
data nodes. So what the data node contains? The actual data in the form of blocks are written to data nodes. Okay, clear enough? So because first thing is this was done internally. So what we do now, from your machine, a client just run a command hadoop fsf and copy and the file name and the directory name. That is, you are going to write this file to the Hadoop cluster. So internally, what happens? This file is divided as a blocks. Then the blocks are replicated. Replicated blocks are distributed to all the nodes, all the nodes or the disks which are configured. So the admin will configure each node, each machine, each disk as a one node. So we call it as a node 1, node 2, node 3, node 4, node 5. These are the 5 nodes. Then what we are writing in these nodes, we are writing the data. The actual input data which we are going to process, that data is written to these nodes. So that we are calling these nodes as a the data nodes. So in each data node, how many file systems will have? 2 file systems. One is a local file system and other one is a SDFS file system. So what local file system contains?
Operating system.
Files, OS related files. Where we are installing Hadoop? In a local file system or Hadoop file system? First we are installing the Linux. In the Linux we are installing
HDFs.
Hadoop, right?
Hadoop.
So that is Hadoop file system or Hadoop installation files are available in which file system? Local file system.
Local file system.
Right, because now this is my C drive, right? In the I install, then the files are available in my local file system, right? So the same thing. So when we install Hadoop, the Hadoop files, Hadoop installation files, Hadoop configuration files are available in a local file system. So never confuse. This is which we are going to work, right? So OS related files, then Hadoop installation files, local file system contains OS related files, Hadoop installation files, Hadoop configuration or binary files, or you can say Hadoop home, right? So Hadoop homes, Cube home, Hive home, so everything is available in a local file system. Then what Hadoop file system contains?
All the data, like all the
input data which we are going to process, right? The input data which we are going to process. Only that data as a blocks are written to SDFS. Now clear what local file system contains, what SDFS file system contains. Now you want to change the a property of a Hadoop. So where do you search? Do you search in SDFS or local file system?
HDFS.
Local file system. Local file system. Suppose, Rashmi, see, what is the question here? Suppose you want to, you are looking for some Hadoop installation file or Hadoop configuration file. So where do you find that file?
Oh, local system.
Local file system. Only the data which we are going to process, that is available in SDFS. So SDFS does not contain anything. Suppose your manager told that, hey, Rashmi, you install HBase in a Hadoop cluster. Then where we have to install HBase, in a local file system or SDF file system?
Local.
Local file system. Very good. Suppose your manager told, Rashmi, take this data and process the data. Then where you have to copy the data? Local or
HP.
SDFS? You have to make the data
HDFS.
available in SDFS. So remember,
Mm.
so all the installation configurations are available in a local file.
Just.
Only input data
Mm-hmm.
which we are going to process, that we have to copy into the Hadoop file system.
Mm-hmm.
Okay, so now you got what we have, the data is going to return to these nodes, and what is a
Yes.
data node. Okay, then so all these data nodes are connected to a one master node. We call this master node as a name node. So Rashmi, you have a textbook of some 1 lakh pages and you don't have an index. Can we able to find a topic or a chapter?
Sorry. What?
uh, uh, I have given you a textbook of 1 lakh pages. So it's a very big
Mm-hmm.
textbook, and I told you to look search for a one particular topic. Is it possible?
No.
It's possible, but it's a lot of time consuming.
Yeah.
Yeah, correct. It
Um,
is possible. You can scroll one page after one page. Sometime you can find it, but it takes a
mm-hmm.
lot of time. But if you have an index,
Mm-hmm.
then it's very easy. Correct.
Mm-hmm. Yes.
Correct. The same way, we keep writing the files to the data nodes like this. Now the user is writing multiple files. Then how do you locate which files are available in which directory? Where you copied this prodinfo.txt, who copied, when he copied, what is the size of the file. So you need some file to find out the files, right? To find out the
Mm-hmm.
information about the data which you are going to put it in the data nodes. So that we are going to write into the name node. So,
Name.
so what name node contains? Index of the data, or you can say reference of the data in data nodes, that is written into the name node. It's very simple, Rashmi. What name node contains? So what is the file name we are going to copy here? Prod underscore info.txt. So the file name prodinfo.txt is a file name which is I'm going to copy. What is the file size? 1000 MB. What is the replication factor for this file? 3. Who created this file? Rashmi. Belongs to
Mm-hmm.
which group? Hadoop dev group. Right? So what is the
Mm-hmm.
privileges this for this file? Read, write, and execute.
Mm-hmm.
All the privileges. So like this one particular line, this like this information written to the name node. Okay. So only this line. Whenever you write a file, the name of the file, the size of the file, replication factor of the file creator, owner of the file, the group name, and the permission. This is written to the name node.
Mm-hmm.
Now you got it. What name node contains?
Yeah.
Index of the data in a data
Data.
nodes, or reference of the data in a data nodes. So in a simple, right, very practical, if you see that the name node contains this
All the
information,
data.
name of the
Mm-hmm.
file. Then the
Mm-hmm.
content of this prodinfo.txt is available in the
In
data nodes.
the
The
data.
reference
Yeah.
line is written into the name node.
Mm-hmm.
Okay. So any confusion here?
No.
Okay. So now you know what is a name node and what are the data nodes. Okay. So now, okay, client what he did, he copied the file to the Hadoop cluster. How he copied? Using a copy command. So when he copied the file is divided as a blocks,
Mm-hmm.
and the blocks are replicated blocks are distributed. Then,
District.
so where we are writing the data, so that they are the data nodes, the file information, the path, metadata is written into the name node.
Name.
Correct. So now, what client will do after copying the data? He will run a program. Correct. He want to query the data. he want to perform processing the data. So the client, what he did, he wrote a query. Select count of stars. He want to count the number of products from prod info. Okay. So what client did? Client or the user or from your desktop machine, you are trying to write a program. What is the program name? Some query. Select count star from the prod info. So when user runs a query, now the query is executed taken by a process called JobTracker. What we have? We have a
Job
JobTracker is
tracker.
available. Right? Generally,
Mm.
so JobTracker available in the machine where we configure the name node.
Mm.
Okay. So what this JobTracker will do? This JobTracker will take the request from the
Mm.
client. Right? Who will take the
Mhm.
request from the client? JobTracker.
Job tracker.
Then what
Mm.
it will do now after taking the request? Now it has to locate the file prod underscore info. Then
Mm.
job tracker identifies where do you find the information about this prod info. You have to locate into the index metadata, right? It
Mm.
checks in the
Mm.
name node. What it will check?
Mm.
Where this prod info blocks are available. Then it goes to that particular data node where the blocks are available.
Mm.
Okay. So in each data node, so there is a job tracker. What it is? It is a task tracker.
Task tracker.
Okay. So every data
Mm.
node we have a one task tracker. Every data node
Task.
we have a one task tracker,
Task.
right? So
Mm.
always the task
Mm.
tracker, what it will do now, it will take the request from the job tracker
Job.
and execute the job given by the job tracker.
Mm.
Okay. So here job tracker takes the request from the client and it goes
Mm.
to the name node to locate the blocks where it is available. Then it goes to that particular data node,
Mm.
and in each data node it will have a task tracker. Then job tracker says, hey task tracker, you take this job and execute it. Okay.
Mhm.
Then what task tracker will do? Task tracker will run the program.
Mm.
So as long as task tracker is executing the program, it says, hey job tracker, please wait, I am working. What task tracker says? It says continuously, job tracker, please wait, I am working. It will send the heartbeats, I am live, I am working. So that
Mm.
what job tracker will do, as long as task tracker is running the job tracker is waiting for the task tracker's output.
Mm.
Okay. Are you any confusing, Rashmi, or you are understanding? Did I make
Yeah,
it
I'm
like
understanding.
right?
No, I'm understanding. Mm.
So job tracker will send the heartbeats. What we call it as a heartbeats.
Oh, yes.
Task tracker sends the heartbeats to the job tracker. Hey job tracker,
Mm.
I am working. Please wait. So then what job tracker will do? Job tracker is waiting for the output from the task tracker. When the
Mm.
task is completed, then the task tracker will give the output to the job tracker.
Job tracker.
Then the job tracker submits the output to the client.
Client.
Suppose while the job is running in this machine, this data node goes down. Then
It gets to some other
yeah, some other node where
domain.
the same
Mm.
block is available.
Mm. Develop.
Okay. Then again job tracker goes to that particular data node and it assigns the job to the task tracker which is available in that data node. But then
Mm.
again the same thing. Task tracker says, yeah, job tracker, please wait, I am running the job. So as long as task tracker is running the job tracker is
Mm.
waiting for the output from the task tracker.
Mm.
Okay,
Mhm.
right. So now what we have seen here, the name node and job tracker. So both are available in a which machine? Master or slave?
Yes. Uh, master.
Right. So we can say like Hadoop, these are the Hadoop master daemons. Okay. So what are the slaves?
Task tracker and data nodes.
Yes, data nodes and task trackers.
Task trackers.
So who will take the client request?
JobTracker.
Right. Who runs the job all the time in a Hadoop cluster?
Who runs the job?
Right.
TaskTracker.
TaskTracker execute the job. Okay. So, right, now you understand what the data node goes down. So it is going to some other data node. It runs the job. Correct? So no
Yes.
confusion till
Yes.
here.
Yes.
Okay. Suppose if the name node goes down,
Yeah, we have secondary name node.
so Rashmi, remember this sentence as it is. Okay. So
Mm.
name node is a single point of failure
Oh,
in a Hadoop
same here.
cluster. Okay. So
Mm.
name node is a single point of
Single thing.
failure.
Failure.
That means if your data node goes down, nothing is going to be happen. But
Mm-hmm.
if the name node goes down, the entire cluster is
Mm-hmm.
a
That was
down.
down. Mm.
So what we are doing here to for this, we are taking another node. Okay, we call this
Yeah.
as a secondary name node.
Name node.
What we calling this? We calling this as a secondary
Secondary
name node.
name node.
So what we do now? So first we write the data into the name node. Then we take the backup of the name node to the secondary name node.
Mm-hmm.
Okay. So see here. What secondary name node contains? The definition is snapshot
Mm.
image of primary name node.
Mm.
Okay. So in a frequent time, that is, you know the checkpoint. So
Yeah.
first suppose 10:30. Right now
Mm.
10:30. So what we did,
Mm.
we took the backup of name node 1 to secondary name node.
Mm.
Okay. So next save point time is 11:30. Okay.
Mm. Mm.
Right. It's first 10:30. So the backup is taken to the secondary name node from the one name node to secondary name node. So what is the next backup time?
11:30.
11:30. So you have backup data available secondary name node till 10:30. Now
Mm.
consider at 11:25. Suppose if your name node goes down at 11:25. So can we able to retrieve the data between 10:30 to 11:25?
No.
So do we have backup available in secondary name node which is 10:30 11:25?
No. I
No.
don't.
Right. So here we are not getting the data if we are using a secondary name node.
Mm.
Now if you observe this architecture, there are the two issues, Rashmi. One is what the job tracker is doing while task tracker is running the job.
What? Sorry?
While task tracker is running the job, what job tracker will do?
We will just wait.
Yes, job tracker is waiting for the
Mm.
output from the task tracker. So it won't do anything. So can you able to run a second job?
Mm.
No.
No.
So job tracker once it will take a request from the client. So till it gets job completed, now it cannot able to take second request.
Mm.
Okay. So in this architecture, the issue is no parallel processing. We cannot able to run multiple jobs because job tracker is waiting for the out from the task tracker.
Mm.
Okay. So what is the issue
Mm.
here? No
Parallel processing.
parallel processing. That means we cannot run the two jobs at the same time because
Mm.
job tracker is busy with the job one. So once it's
Mm.
completed, then only it can able to take the second request. So I
Mm.
cannot able to run the multiple jobs at the same time. That is the one disadvantage. No parallel processing.
Process.
And what is the thing is high availability. Some point of the time we are going to lose the data. Correct?
Data.
No
Mm.
100% high availability. Anyway, up to 10:30 I can able to retrieve. But the data which you wrote between 10:30 you need to lose the data, which is very considerable, right? So
Mm.
no 100% high availability. So these are the issues here, correct? So
Mm.
we call all these are the Hadoop daemons.
Mm.
Okay. So this above is a master, right? Hadoop architecture is a, now this part is a master nodes and these are the slave nodes.
Slave node.
So name node, job tracker, second name node is a masters,
Master.
and data nodes and the task trackers are the
Task.
slaves.
Slave node.
So when we are using a job tracker and a task tracker to process the data, we are facing two issues. One is a no parallel processing and no 100% high availability. Okay, so this is generally the Hadoop which we are going to use, Hadoop before 2.0.
Mm-hmm.
Okay, so that is Hadoop before 2.0. So now always we talk about Hadoop two ways, Hadoop before 2.0 and Hadoop after 2.0.
Okay.
Okay, so Hadoop before 2.0, master diamonds are the name node and the job tracker, slaves are the data nodes and task trackers. You can name node, job tracker, and we have a secondary name node, correct? Then
Mm.
Hadoop 2.0. Now what we did, so we have to avoid these two issues, correct? No parallel
Mm.
passing, we have to avoid. Now what I do now, instead of the job tracker, we use a yarn. What we are using? We are using
Yarn.
yarn. So it's very simple, Rashmi. Previously there is a one employee has to work. Now we are using the two employees. Okay, so that we have to use a yarn. Okay, so Hadoop 2.0 onwards, what we are using? We are using yarn. Yarn stands for yet another resource negotiator. What it stands for? Yet another resource
Resource.
negotiator.
Negotiate.
So what I did now, so previously only one job tracker has to do all the things. Now what I'll do, the yarn contains a resource manager and application master. That is, we have instead of a job tracker, we use resource manager. Okay, instead of the job tracker, what we contain? It contains a resource manager. Instead of the task tracker, we use a node manager. Okay, right.
Mm.
So now the job tracker, instead of the job tracker, we use a resource manager. Resource manager, we use the two process. One is resource manager and we have a application master. Okay, so resource manager and application master, together is a resource manager, right? It's a one job role, two people are working. Okay, now Rashmi, see here, I am a resource manager. Okay, Rashmi, you are an application master. Okay, so first what I'll do, as a resource manager, I'll take the request from the client. Okay,
Mm-hmm.
then I'll assign this job to the node manager to run, and I tell, yeah, application master, Mr. Rashmi, you are working as application master, you monitor the job. So who is monitoring the job now?
Application
Application
master.
master is managing the job. Who is running the job?
Resource manager.
Node manager running the
No.
job.
Oh, non member.
Node
Yeah.
manager
Okay.
is running the job. So in this time, resource manager will take a second request. Got it? See, I'll repeat again. So I am a
Mm.
resource manager and you are an application master. So what I'll do now, as a resource manager, I'll take the request from the client. Then I'll go to the data node and I'll assign this job to the node manager. Hey node manager, now you run this job. So node
Mm.
manager running the job. Then I'll tell Rashmi, you are an application master, so you have to monitor the job. So now what
Mm.
you do now, you are monitoring the job executed by the node manager. So you both are busy in one job, so I can take a one more request from the client.
Mm-hmm.
So can we have a parallel processing now?
Yeah.
Yes.
Yes.
That is, so in the ER, instead of the job tracker, we are using a resource manager application master, and instead of the node task tracker, we are using a node manager, so
Manager.
that we achieve a parallel processing. Okay, parallel processing is available. So when we use a yarn, okay, so yarn contains resource management,
Yes.
application master, and instead of the task tracker, node manager. That is, in every data node we have a node manager,
Node manager.
right? Instead of the task tracker, in every data node we have a node manager.
Mhm.
Okay, so now high availability. How we get the high availability? Now I am taking one more name node, extra name node. Okay, so we call it as a HA node. What we call? We call it as a HA node.
Actually,
HA stands for high
high.
availability. We call it as a HA node. It's simple, Rashmi. What I do, two writes. Whatever I write here, the same I'll write here.
Mhm.
Okay. So if I am writing something here, immediately that will return to this node. Okay, so the admin will configure auto fencing. What it will do, he will configure a auto fencing. That means if this is done, then automatically it will up and run. You don't need to do anything. So if the primary name node goes down, then immediately h node will active and it will run. So there is no downtime.
Mhm.
Got it?
Okay.
So it's very simple. In Hadoop 2.0 onwards, we are taking another extra node. We call it as a HA node, high availability node. And we are making two writes. That is, whatever we are writing, whenever we are writing, immediately that also we write into HA node, two writes.
Mm.
Okay. And
Mm.
so we configure a auto fencing, means automatically it will up and run if this goes down.
Okay.
So there is no downtime. Okay, so my question to you, Rashmi. So in a Hadoop cluster, how many name nodes we can have?
Mm. We can have only one name node, but we will have like as a backup Apache node.
No, before that, you have to ask one more question to me. You're talking about Hadoop before 2.0 or
Yeah,
Hadoop after 2.0,
2.0. Yes. Yeah.
right? First,
Yes.
immediate next question is you're talking about before 2.0 or after. In a before 2.0, we used to have only one name node.
One name node.
And
Oh, yes.
2.0 onwards, we can have multiple name nodes. Now, you can take three
Oh,
writes, three nodes. You can take five
oh,
nodes. It's up to you. But only one
okay.
should be active. Okay,
Okay.
right?
Mm-hmm.
So Hadoop 2.0 onwards, we can take multiple name nodes.
Mm-hmm. So
Okay,
why we need the secondary name node then in that
sorry.
case? Like
No,
why we
we don't need importance to secondary name node from 2.0.
okay.
So no, not priority will be given to secondary name node. It's optional. So Hadoop 2.0 onwards, no priority to the secondary name node.
Okay. Okay.
Okay, but
Okay.
we use secondary name node because if you keep writing the data, so it is going to be filled completely, right?
Mm-hmm.
So as you're writing the metadata, it's occupying some memory. So how many days you continuously write into the name node? You want to make the cluster runs faster. So what do you do now? So whatever I am writing the name node, I'll take it to the secondary name node, then I'll flush out. I'll remove everything from the name node. And
Okay.
don't forget, Rashmi, name node is a primary memory. Okay, that is whatever you're writing the name node, you're writing into the RAM.
Yes.
Okay,
Okay.
so RAM means what? If it is goes down, if you turn off the machine,
Mm-hmm.
right, it doesn't
All
store
the
anything, right? So
mm-hmm.
that's a name node always writes the data into primary memory, and in the data nodes, every time we are writing the data into secondary memory.
Mm-hmm.
Okay,
Okay.
so primary memory, suppose simple, you are using a mobile, in your mobile, suppose if you are using some Android mobile, so you are using a 2 GB RAM, so as you open the applications, your RAM is going to be decreased. So when you close the applications, or if you close all the applications, again you will get a 2 GB memory, correct, complete memory. So
Mm-hmm.
the same thing now here. So this is a primary memory. As you're writing the data, that data completely fills into the RAM. So then what we do now, we take the backup in secondary memory, we'll delete everything from the memory.
Okay.
So now the backup is available secondary name node.
Okay.
right? That's a little bit more. We have FS image file, edit logs are there. So it goes a little bit more architecture there. Okay.
Okay.
Yeah. So now Hadoop 2.0 onwards. So what are the master nodes, Rashmi?
Resource manager
First name node,
name.
then HA node.
Node.
Okay, name node, HA node. If you have a secondary name node, then uh, if you have a resource manager, if you are using yarn, we can also have a job tracker.
Job
Both we can
tracker.
have both, right? So I can run
Mm-hmm.
some jobs with the job tracker and I can run some jobs with the resource manager.
Mm-hmm.
Okay, so what are the masters here?
Name node. H
Right. HA
HA
node,
node
secondary
and
name node,
HA
secondary
node.
name node, high availability node, resource manager, Z. Now this HA node, some people will call it as a journal node. Some people say quorum node. Some people will say it shared node. Okay.
Mm-hmm.
With different people will use the different terminologies. It's generally we use it as HA node. So you can see some people will say this as a shared node.
Mm-hmm.
Okay. So don't get confused. Now what are the slave? Slaves are,
Data nodes
yes, data nodes,
and
task node manager
task
if you have, yes,
node.
node manager if you have a task tracker. So these are all
Mm.
the slaves. Okay,
Slaves.
so always resource manager and application master together is a resource manager. Okay, so we don't differentiate
Okay.
separately. It's a two process together. It's a resource manager and application master together we call it as a
Application
resource manager.
manager.
Okay. And sometimes we configure the servers here in a Hadoop cluster when we're working. So generally what we do, we when we are going to install HBase, so we use HBase as in a one master. Okay.
Mm-hmm.
We configure HBase as a master and we install HBase in the two data nodes. Okay. So now this
Mm.
is a HBase master, which also which is also known as a master node. Okay.
Master.
So this is a HBase master. Sometimes some people will configure Hive as a master. So it's a Hive server. Okay. So these are all comes, these also comes as a master nodes. Okay.
Okay.
So apart from this one, so we have a HBase master. So when we have HBase master in a master, then HBase regions or HBase slaves are the slave nodes.
Mm.
If we configure Hive server, Hive clients are the slaves.
Mm.
Okay. So these are the Hadoop daemons. Okay. So now, right, generally what we do, we represent it as like a master and slave. But in
Mm.
really when we are working, we don't differentiate with a master and slave. We always differentiate with SDFS, then a map reduce, or then a yarn. So we can
Mm-hmm.
say, so your manager says, yeah, Rashmi, start SDFS. Then what you have to start? What are the SDFS domains? So where we have
And
the data nodes. Okay, so we always use name node, data nodes or the SDFS file system related. Okay,
mm-hmm.
so these are the SDFS daemons. Then what are the map reduce daemons? If you are using a job tracker,
Job
then the task tracker. So these are the
also
map reduce. What are the yarn daemons? If you are using a resource manager,
a
node
manager
manager. So these are the
node.
yarn daemons. Right? When we
Mm.
are representing here, we are learning it as a master and slave. When we are working, so you'll get the like, so run this job with a map reduce. Then you have to use
Mm-hmm.
job tracker and task tracker to run the job. So your manager says
Mm.
execute this job in a yard. Then you have to use a resource manager and node manager.
Node
Suppose,
manager.
yeah, Hadoop cluster is running successfully.
Mm-hmm.
What it means in that Hadoop cluster, SDFs is running, so we can able to store the data. Then MapRed is running, we can able to run the job.
Of course.
Suppose only SDF is running. Okay, only SDF is
Mm,
running, then no map rate, no
mm.
yarn. Can we able to run the job?
Yeah, we can store the data at least.
Yes, we can only store the data, but we can't able to run the job,
Process.
right? So to run the job, we have to start either a map reduce or have to use a yarn. Okay, so
Mm.
now we have to. So if you say Rashmi start the map reduce, then what you have to start?
Mm. Still, we have to start the HTML, right?
No, HDFs, it's a different. You have to start the
Okay.
HDFs means you have to start the name nodes and data nodes. If I say start the map reduce, then you have to start job tracker and task tracker. Suppose if
Task.
I say start the yarn, then you have to start resource manager and
Resource name.
node manager.
Name.
So we
Name
use
manager.
these terminals. Now we don't say master and slave. So we'll get,
Mm-hmm.
so run this job with the map reduce. Then you have to use job tracker and task tracker to run the job.
Mm-hmm.
If somebody says run the job with a yarn, then you have to use wrap or resource manager and node manager. So
Name
anyway,
manager.
all the time we have the data in a STFS,
HDFs.
right? So this is what
Mm.
we call Hadoop diamonds or the Hadoop processes.
Mm-hmm.
Right now you got a clear idea what is a name node, what are the data nodes, what job tracker will do, what the task tracker will do, what is a HA node, what is the Hadoop difference between before 2.0 and Hadoop 2.0, how the blocks are replicated, how the blocks are uh, distributed. So this is what we discussed today. Did I make
Mm-hmm.
any confusion, Rashmi, or it's easy?
No, no, no confusion.
Actually, it is very difficult for everyone. Nobody understands. Right? If you
Yeah.
see most of the interview, you'll get the same topics, same questions, right? So you may get so many questions from this topic, what we discussed today.
Mm-hmm.
Okay, so anyway, I'm pasting the diagram here, so you can use the reference. Okay, so in tomorrow's session, we discuss about Hadoop file system. The same thing, distributed files, right? So again, we learn Hadoop file system.
Mm-hmm.
Okay, so we discuss Hadoop file system, and after that, if you have a time, we learn how to connect to Hadoop cluster.
Okay.
So do you have Hadoop configured in your machine?
No, actually, I have like virtual machine Cloudera.
Okay, so you have Cloudera. Fine, that works. New version, right? 5.7 or 5.8.
That I don't know, but I just downloaded somehow like